The ground improvement techniques are the procedure to enhance the engineering properties of the soil. The main objective in this ground improvement techniques are the slope stability, uh, control settlement, and alleviate liquefaction. I have had here the slope stability video. In hilly terrain. We have the problem of slope stability when there is raining, so uh, the soil becomes soft, and due to its self-weight, it's erode and landsliding occur, which disturb our the infrastructure. In this video, you have seen they wash out the road with itself. Now, moving with the techniques which we are using in practice. Some are the conventional methods and some are the advanced. In conventional methods, we do excavation and replace it with the good soil, and it is also used commonly. But here in this presentation, we will discuss the advanced method one by one, which is listed here. So, moving toward our first method, in advanced method, that is explosive method. In explosive method replacement method, this deep densification of soil is done. In this method, the explosive mm, material create voids which are filled with crushed stone or some material which modify our soil properties. Here is the one of the video in which the four or five PhDs claim that this type of test has never been done in the world for soil for the explosive blast techniques of soil enhancement. So they drill the probes and inserted the dynamites and the different sensor. This is done for the residential buildings and enhancement of the soil. This was one of these short video which was available on YouTube. So animation for this video was not available, so I have added this video. The second method that is Vibro flotation method. In this method is also used for the soil compaction, and I will discuss the method of application in the detailed video which I have cropped and presented in the shortest possible way. In Vibro flotation method, a probe is inserted with the water and air, pressurized water and vibration to the soil. You can see there this is vibrating and also sprinkling the water. When it reaches the soft strata, the water injection is stopped and the material is inserted. After the material is inserted, with the vibration, the densification and compaction is done. When it's reached the soft strata, the water jet is stopped, and only with the vibration, the compaction is done. And in this method, the soil is enhanced in such a manner. The third method is the dynamic compaction method, which enhances the soil properties. It's also densifying the soil and fill material by using a drop weight. In this method, heavy weight is dropped on the ground surface with a regular grid of impact points. I will show here the regular grid impact points in this video, and the complete process how it is done in phase 1. The heavy weight is applied in grids on the soil, then backfilling of cutters again in after this phase 2. The remaining grid points, the space between, is also applied with heavy weight, and again it is filled. After this step, the ironing is done and roller compaction. When rolling compaction is done, the post improvement test, the CPT and PMT tests are done for the reason is the soil is enhanced or not. So this was all about dynamic compaction. Now the fourth one is the jet grouting. It is also used for the cohesionless soil to densify it. In this method, high pressure air, water, and cement grout are injected with a high velocity. The concrete alongside of soil is called soilcrete. I have also added a video for this jet grouting, which is a probe is inserted in the ground and with the pressurized jets, the cementation material is inserted in the ground. So jet grouting is done in this manner. The other method is the lamp stabilization method. It is almost done on the surface of the uh, soil. This method increase the plastic limit of the clay. First of all, the clay in the soil is extracted from the side. Small amount of slurry is added and left for 1 to 4 days, and then the slurry is mixed and which reduce the plastic index and increase the plastic limit of the soil. Here is one picture in which the l- lime is mixed with the soil, and after this lime mixing, the surface is compacted, which increase the plastic limit and the decrease the plasticity index of the soil. In this manner, with the lime stabilization, the soil is enhanced. So the fifth method, we have the deep soil mixing. Uh, it improves the compressive and shear strength of the soil. It is something like the jet grouting, but the in this method, the cementation and pozzolanic material is mixed inside the drills, in which I have a video here for you with pressurized. With this auger of uh, the auger will be showed here in large picture blender injection. So because of this blender injection, this is called deep soil mixing, which with the help of this it increase the compressive strength and shear strength. You can see uh, a big block is placed here, so it shows that the shear capacity of the soil is also enhanced. The last method we have here, the prefabricated vertical drains, PVDs. It's the shortening of used for the shortening of pore water travel distance. It's reduce the preloading time, reduce the potential down drag on piles, and increase the storage capacity for future landfill and waste containment. The method of application is will be explained in this video very clearly. The prefabricated synthetic core in which the you can see these are the water drains and protected by a layer of high water permeability. Its main objective is high mechanic strength. So it is applied like this with anchor plate and main drill. With the help of this main drill, this is inserted in the ground deep down, and after it reaches to the specified strata, the main drill is removed and the synthetic PVD is remain in the soil, which act as the water path for the movement of pore water. So in this way, it enhances the properties of the soil and elongate the settlement time. So the main conclusion of the ground improvement techniques are to mainly we want to move toward the smarter choice of our foundation. For the smarter choice and advanced selection from traditional foundation selection to a modified one, we used ground improvement techniques which save our economy over time and give us the good option. Uh, to select our foundation wisely and smartly. This was all from my side, and my presentation ends here. Thank you, sir, for allowing me to present this topic.
Thank you so much, Nadeem. The presentation was excellent, and the videos were excellent. They were more interactive as well. So we now understand that what is how we can achieve the compaction using blasting, vibro flotation, dynamic compaction, jet grouting, lime stabilization, deep soil mixing, and the PVDs. So thank you so much for your participation. If you have any problem with your sessional marks, or if you want to recheck the final term paper as well, so please kindly contact me. I will definitely give you extra sessional marks, so it will enhance your grades as well. Thank you very much. Next presenter,
Thank you,
please.
sir.
Excuse me, sir.
Yes, please.
सर मैं स्टार्ट कर लूं?
Yes, please. अपनी स्क्रीन शेयर कर लें.
Is my screen visible, sir?
Yes. Click on it. Yeah.
Okay, sir.
Time is 9 a.m. 10 minutes maximum, please.
Okay, sir. Sir, I have actually I was adding the videos, but then there was some error. So I have, sir, I will play the videos separately at the end of my presentation, sir.
Okay, no problem. Please continue.
Bismillahirrahmanirrahim. This is our presentation topic: various ground improvement techniques in geotechnical engineering, and this will be presented by our group members: Muhammad Israr, Muhammad Ali Khan, Adnan Sami Khan, Hamza Khan, Junaid Ali, and Sayyid Inamullah. Now, what is ground improvement? It is basically the procedure in which we are using mechanical means to improve the poor ground condition. These help us to improve the engineering property of the soil mass, which is treated to meet the project performance requirements. These refers to a technique that improves the engineering properties of the soil. Usually the properties that are modified are shear strength, stiffness, and permeability. Ground improvement has developed into a sophisticated tool to support foundation for a wide variety of structures. Now the question arises, why do we need ground improvement? We need ground improvement to prevent excessive settlements of the surface of the reclamation area where structures like buildings, road, and other foundation are loaded on it. We want to improve the shear strength of the fill and subsoil to ensure sufficient bearing capacity of the foundation or sufficient stability of the slope. We want to increase the density of the fill mass or subsoil to prevent liquefaction. And we also want to improve the soil permeability in order to increase drainage capacity. Now, various ground improvement techniques. First one is Vibro Compaction. It is the rearrangement of soil particles into a denser configuration by the use of powerful depth vibration. It is a ground improvement process for densifying the loose sands to create stable foundation soils. The combined action of vibration and water saturated by jetting the rearranges loose grains into a more compact state. It is usually performed with specially designed vibrating probes, usually 12 to 16 inches in diameter, and which vibrates at a frequency typically in the range of 30 to 50 Hz. After the probe reaches the required depth of compaction, the granular material, usually sand, is added from the ground surface to fill the void space created by the vibrator. I have attached the picture, and inshallah in the end I will show a small clip of it. Now, vacuum consolidation. It is a method of applying vacuum suction into an isolated soil mass to reduce the atmospheric pressure in it, thus reducing the pore water pressure in the soil. The effective stress is increased without changing the total stress. It is an effective means for improvement of saturated soft soil. It can provide an equivalent preloading of about 4.5 meter high conventional surcharge fill. Vacuum assisted consolidation preloads the soil by reducing the pore pressure while maintaining a constant total pressure. The third one is preloading of soil. It is an economical and effective soil improvement method that reduces the settlement and increases the bearing capacity of soft soil. It forces water out of the soil matrix, facilitating soil consolidation. Preloading or pre-compression, it is the process of placing additional vertical stress on the compressible soil to remove pore water over time. The soil treated usually are organic silt, warped silts, clays, soft clays, dredge materials. Now, thermal stabilization. It uses an electrical current to heat the soil and modify the physical characteristics of soil. Thus, electrical repulsing between the clay particle decreases and the soil strength is increased. Heating the soil permanently alters the properties of soil. Depending on the soil temperature can range between 300 to 1000 degrees Celsius. The impact on adjacent structure and utilities should be considered when heating when this process is used. Fifth one is ground freezing. It is also a construction technique used in circumstances where soil needs to be stabilized so it will not collapse next to excavation or to prevent contaminant spill into soil from being leached away. In this process, we use the refrigeration to convert pore water to ice. The ice then acts as a cement or glue bonding together the adjacent particles of soil or block of rocks to increase their combined strength and make them impervious. This is things to be considered while doing this test is thermal analysis, refrigeration system, geometry, thermal properties of soil and rock, freezing rates, energy requirements, coolant/refrigerant distribution system analysis. Soil nailing. It is a construction remedial measure to treat unstable natural soil slopes or as a construction technique that allows the safe oversteepening of new or existing soil slope. It is usually feasible for soil in which the excavation is constructed and is able to stand unsupported in a 1 to 2 meter, usually 3 to 6 feet high vertical or nearly vertical cut for 1 to 2 days. It usually uses grouted tension resisting steel elements to reinforce the soil and creating a gravity retaining wall for permanent or temporary excavation support. The seventh one is Vibrostone columns. These are also known as Vibro replacement, and it is the construction of dense aggregate columns, usually stone columns, with the downhole vibrator suspended from a crane or specially built rig. The stone columns are intervening soil and the other integrated foundation support system having low compressibility and improved load bearing capacity. These columns are constructed using a vibrating mandrel which is used to penetrate the ground to a design depth. This creates a void which is filled with inert granular material. Usually इसमें हम सर void create कर देते हैं, then इसमें granular material, we pour granular material in it, and this continues. The result is an interaction between the stone column and the surrounding soils. Number 8 one is micro piles. These are small diameter piles up to 300 millimeter with the capability of sustaining high loads, compressive loads of over 5,000 kilonewton. These are also known as mini piles, pin piles, needle piles, and root piles. Micro piles, they are generally used when there are difficult ground conditions such as natural or man-made obstruction, sensitive ground with adjacent structures, limited access, and karstic geology. Number 9 is grouting. It is the injection of plumbable material into a soil or rock formation to change the physical characteristic of the formation. While doing grouting, we should consider site-specific requirements, soil type, soil groutability, and porosity. Grouting is usually prevented by collapse of granular soil settlements under adjacent foundation, utility damage, and daylighting. The purpose of grouting is either to strengthen a formation or to reduce the water flow through it. It also used to correct the faults in concrete and masonry structures and predictable degree of improvement. And jet grouting, it is also a type of grouting, and it is used by grouting contractor to describe various construction technique used for ground modification or ground improvement. It is the same, but it usually involves the use of ultra high pressure fluids up to 6,000 psi or binders that are injected into the soil at high velocities. These binders break up the soil structure completely and then mix in the soil particle to create a homogeneous mass which in turn solidifies. The grout usually used in jet grouting is a suspension of Portland cement in water. Dynamic compaction. Dynamic compaction, it is a method in which we want to increase the density of the soil when certain subsurface constraints make the methods inappropriate. This process usually involves dropping a heavy weight repeatedly on the ground at regular spaced intervals. It is usually applicable for a wide variety of soil conditions, including saturated, unsaturated, loose sands, even with the presence of silty pockets, dune sands, inorganic fill, reclaimed soils, variable characteristic and sizes, even with the presence of large size boulders and landfill deposit. Thank you. This was all from my side. And sir, I have some small clips so which I want to show you, sir. May I, sir?
Yes, please.
The first one is about the Vibro Compaction. Look, they are inserting the probe in it, and then from the top, they are filling the granular material, which in turn comes down and makes the soil surface rigid. This second one is of vacuum consolidation. Actually, consolidation actually is when we want to take out the water droplets from the sound. So they apply the suction pump from one side and they suck the water droplets from the other side, and then they make it stable for whatever structure they want to design, so settlement will not occur. Then preloading. It is actually a company which has advertised about its they can be trusted with this. So it actually is the advertisement. They actually, they actually have shown that what if we don't have the if we don't have the preloading testing on the soil, so this will happen. The building will collapse. Look, settlement will occur and building will collapse. Then they describe about the solution. So they have not compacted the soil, that's why the settlement occurs. So now they are talking about the preloading and non-preloading, non-compaction of soil. On the right side, they actually allow the soil to compact for a longer time. That's why the building will be stable and settlement will not occur. But on the left side, they actually didn't allow the soil to settle there and construct the buildings on it. So the structure buildings will settle down. This is about the soil nailing. They are inserting the soil. This is the slope. So inserting the nails in order to prevent the slope. They are now applying the plates so that it may not get damaged. They are spraying shotcrete over it so that it forms a firm bond with the soil. Vibrostone columns. The probe is vibrating and they insert it into the ground. Then from the other side, they pour concrete or other mixture in it so that they can form a column and make the soil harder and does not settlement does not occur. This is the short clip about the jet grouting. And this one, last one, is about the dynamic compaction. So usually, a large load is hit from the height so that they compact the soil and prevent the settlement.
Thank you so much, Adnan Sami Khan.
Yes, sir.
It was
Thank you.
excellent presentation, and the videos were also very interesting. Just one comment, okay,
Yes,
on
sir.
your presentation.
Yes,
There
sir.
are ground improvement techniques which we discussed and you also shared with us. For
Yes, sir.
example, the vibro flotation, dynamic compaction, jet grouting, and clam
Yes, sir.
stabilization, root soil mixing. Those techniques are known as ground improvement techniques. While the soil nailing micropiles, these types of techniques are known as ground reinforcement techniques. Okay, so we
Okay, sir.
improve the ground and we reinforce the ground as well. So
Sir,
just to
actually, yes, sir, they are remedial measures for already built structures. We can say that, sir.
fine, that's perfectly fine.
Yes,
Just
sir.
for your learning, okay?
Yes, sir.
We enjoyed your presentation. It's excellent. If you need any boost in your sessional marks, and if you need my help in rechecking your final term exam, and if there is, one or two marks missing from your grade, so I will add that at that stage. So you just come.
Okay,
I'm
sir.
noting down those names of the presenter
Yes,
as
sir.
well. So just come and see me when
Yes,
you
sir.
finish your final exams and when you receive the marks and grades. So
Yes, sir.
just meet me, okay, after the final exam. Thank you very
Okay,
much.
sir.
Next
Thank you.
presenter,
Thank you, sir.
please. Okay, who is next?
सर मैं करूं?
Yes, please, Wasim. Yeah, just
जी
please
सर.
share your screen.
Sir, is my screen is visible?
Yes, screen is visible.
Okay, sir.
43 slides.
Sir, don't
Yes.
worry about it, sir.
Okay,
I
that's
think.
fine. We are starting at 9:16, so try to finish it in 10 minutes. But if it's
Okay,
very
sir.
interesting, you can take a few extra minutes as well. No problem. Okay, please
Okay,
continue.
sir. Sir, Bismillahirrahmanirrahim. My topic of presentation is ground improvement techniques. These are my group members, including me. Mm, My presentation contents are problematic geomaterials and potential problems, different problems occurring in soil, different ground improvement techniques. So these are a problematic natural and fill materials, soft clay, silt, organic soil, loose sand, expensive soil, and loess. These are problematic natural geomaterials, and fill material contain uncontrolled fill, dredge material, reclaimed fill, recycled material, solid waste, and bio-based byproduct. So these are the problematic geomaterials. Natural geomaterial contain expensive soil due to the large volume change in it. These are loess, and fill material. Fill material contain uncontrolled filled, dredge materials, reclaimed fill, bio-based byproduct. So now coming to a second content, different problems occurring. Tilting of structure or overturning look to a leaning tower of Pisa in the residential complex at Minhang district, Shanghai, China. Sinkholes, these are problems occurring in soils. How sinkholes are formed. So this is a technique how sinkholes are formed. Frost heap, liquefaction of soil, earth structure during Mirpur earthquake 2019, September 2019 earthquake in Kashmir. Earth structure during Bhuj earthquake or Gujarat earthquake, January 2001, which killed almost 30,000 people in Gujarat, India, and 136,000 building get destroyed. So unstable rock failure, soil slope failure. Ground improvement techniques. Ground stabilization techniques is distributed into three techniques which contain ground improvement techniques, deep dynamic compaction, drainage or surcharge, electro osmosis, compaction grouting, blasting, surface compaction, dewatering, heating or freezing. And ground treatment contains soil cement, lime admixture, fly ash, soil mixing, deep soil mixing. And ground reinforcement, which contains stone columns, soil nails, deep soil nailing, etc. So ground improvement technique is basic operation is increasing soil density, removing air voids, pour water, changing soil water properties. And ground treatment, its basic operation is changing soil properties by adding soil, fly ash, slag, cement, chemicals, etc. Ground reinforcement, a basic operation is soil and reinforcing material act as a structure in which reinforced element takes majority of load. Ground improvement. So field compaction is the least extensive method and simplest method. So field compaction equipments are smooth wheel roller, pneumatic or rubber tide roller, sheep foot rollers, tamping foot roller. And now coming to the dynamic compaction. Dynamic compaction was first used in Germany in the mid 1930s for both cohesive and cohesionless soil. So its basic operation is drop a very heavy weight onto the soil from a relatively great height. Vibro Compaction. Vibro Compaction is established ground improvement method for stabilizing granular soil such as loose sand, gravels, and some hydraulic fails. Preloading or vertical drains. Vertical drains are installed under a surcharge load to accelerate the drainage of impervious soil and thus speed up the consolidation. Prefabricated vertical drains or PVDs. Prefabricated vertical drains are artificially created drainage paths which are inserted into the soil, a soft clay subsoil for accelerating consolidation of fine-grained soil by promoting radial flow or drainage. Ground freezing. Ground freezing is used for groundwater cutoff for each support for temporary underpinning for stabilization of earth for tunnel excavation to arrest landslide and to stabilize abdomen mine shafts. Now coming to a ground treatment. So ground treatment contains soil cement stabilization. Stabilization using cement or other admixtures such as fly ash, blast furnace slag has been adopted in many geotechnical and highway engineering projects. These applications include shallow depth application in the case of improvement subgrade, subbase, and base course of highway and embankment materials. Stabilization of deep soils such as soft soils and peaty soils. These are soil mixing and deep soil mixing. The process of deep soil mixing. And then coming to a shallow soil mixing. A shallow soil mixing is one variety of mechanical soil mixing technology. This technique is applied to improve the foundation soil and prevent settlement of road embankment and building as well as to modify the stabilized contaminated soil. Now coming to a ground treatment. So ground treatment contains mechanically stabilized soil, grouting, injection of a slurry or a liquid solution into a soil or rock formation. Modes of grouting. These are modes of grouting. Stone column installation. A stone column, a ground improvement technique to improve the load bearing capacity and reduce the settlement of the soil. Stone column consists of crushed coarse aggregate of various sizes. Soil nailing. With soil nailing is a method of reinforcing the soil with steel bars or other materials. Gabions, which we all are familiar, ये हम लोगों ने अक्सर गाँव में भी देखे होते हैं. The term Gabion refers to modular containment system that enables rock, stone, or other inert materials to be used as a construction material. Module or cage, they are known or formed of wire meshed fabric panels jointed to form square, rectangular, or trapezoidal shaped units. Micropiles. A micropile is a small diameter drilled and grouted respected pile that is typically up to 20% reinforced. A micropile is constructed by drilling a borehole, placing reinforcement and grouting the hole. Micropile can withstand axial or lateral loads. These are all from my side. Thank you so much for giving me such a opportunity to present something with you guys.
Thank you so much, Wasim. I particularly liked about the difference which you presented between the ground improvement techniques and the ground reinforcement techniques and the ground treatment techniques as well. So that was really really interesting. Thank you so much. And if you need any boost in your sessional marks and rechecking of your final term paper and grades, please just let me know after the final term.
Thank you
Thank
so
you.
much, sir.
And at this
Thank you
time,
so
you
much,
can
sir.
present, please.
Yes, sir. Sir, is my screen is visible and my voice is clear?
Yes, your screen is sharing. Yeah, and voice is clear as well. So we are starting at 9:24 a.m. So maximum 10 minutes.
Sir,
Thank you.
in the name of Allah, the most beneficent, the most merciful. My name is Mohammed Shah Marshad, and these are my group members Hassan Khan, Faizan Ali, Mursaleen Khan, Huzair Amjad. So first of all, I am very thankful to you. After studying this topic, I came to know that it is very interesting and very important and very essential topic for any civil engineer to know about that. Because as a civil engineer, we are always dealing with the soil, and the soil is complex in nature, and because it is a natural thing, and natural things are always complex, it is also an heterogeneous mixture. So we are always dealing with this soil because our any structure is built on the soil. Because any structure like dams, bridges, infrastructure related buildings, we design these all by considering the properties of ground. If we are not considering the properties of ground, it will cause some disaster after some time, because settlements and other failures will occur. So ground improvement is used whenever we encounter poor soil condition. Whenever in the site we have poor soil conditions such as loose sand, soft clays, highly organic deposit, or damped heterogeneous material, then we are going to improve this soil condition. Because when there is lack of good quality granular material need for construction of dams, embankments, or road or foundation, we are always going to make it better for our construction. I think today in the most of the world land are subjected to urban or industrial development. Therefore, good construction sites are difficult to find. Whenever good construction sites are difficult to find, then we are going to soil improvement techniques, or most frequently, which are commonly economically used. This ground improvement technique is emerging branch of geotechnical engineering, because whenever we are going to make on the soil our any structure, we are going to find its bearing capacity, which is then on the basis of bearing capacity we decide its foundation, whether it's we are going to make its deep foundation, shallow foundation, and also another concept is ground improvement techniques. So it is very important to know about the soil behavior for every civil engineer. We are doing to this ground improvement to improve engineering properties of soil, the behavior, to improve the characteristics of soil. We have two things when we are going to make ground improvements. We have two things: bioclogging or biocementation. Means bioclogging is that production of pore filling material. Whenever we fill when we have, for example, we have sand, it has very high permeability, so we pour it clay material to decrease its permeability. Like that we are going to make our ground improvements. Sir, what happens when we ignore ground improvement? It causes settlement, failure, cracks in the structure. These are the first some example when they ignore the ground improvement for their soil to making the structure. Sir, also sinkholes. Whenever some people make houses and don't consider the behavior of soil which is beneath their houses, so means not studied about the substructure. So after some time, this is the process. Rainwater will come, acidic water, limestone, and make a hole below their houses, and they all will bulge through it. So these all phenomena will happen whenever we ignore ground improvement. So what happens when ground liquefactions in the roads? They are makes cracks and ground heaving, ground cracking. All things will be happen. So this is the example which my colleague will also discuss about that. This is happened when the landsliding, the slopes, soil slope failure, because the geological study is not involved in this. So that's why these failures will occur. So let's start. What is ground improvement? Why we are studying ground improvement? Understanding ground improvement. Why study geotechnical structure failures? Because ground improvement techniques refers to improves the engineering properties of soil. Means whenever the soil has low shear strength, low permeability, low compressibility, we are going to make it better for us to increase its shape. Properties of soil, usually the properties that are modified are shear strength, stiffness of soil will increase, and permeability. Ground improvement has developed into a sophisticated tool to support foundation for a wide variety of structure. Why ground improvement? Increase shear strength, reduce permeability, reduce compressibility. Understanding ground improvement. Ground improvement includes two parts. First of all, understand the ground. What is the behavior of my ground? What is the bearing capacity of my ground? Then find the most efficient engineering solution for improvement. Every technique is not used for every soil. Different soil has different techniques to improve their condition. So why we study geotechnical structure failures? It's mean engineering means whenever we want to make our structure, any type of structure, we want to make it economical, safe, means durable. It will not fail after some time. It will be durable for lifetime, and also strong. These are different techniques used for the ground improvements. Ground improvements, ground treatment, and ground reinforcement. Whenever we want to make our soil better for our structure to take all the loads, then we are use these different techniques. Means ground improvement we do, ground treatment, in ground improvement we have different methods. Also in ground treatment we have different methods, and also in ground reinforcement we use different methods for improvement of soil. So I have watched lot of videos, but I only consider 3 videos because it is a very interesting. You also want to go to search about that and must know the concept of ground improvement. The first video I will show you, that is Vibro Compaction. It is also we use the FLAG 3D software for ground improvement. So let's start at Vibro Compaction. Sir, my voice is clear and screen is visible to you.
Yes.
Sir, this is the first technique which mentioned that for used for ground improvement. Vibro compaction. This is the first technique which is used for ground improvement, which I mentioned in this my presentation. So second is Vibro replacement stone columns. So let's start this video. So it inserting the in the soil. And put granule material in this. It will touch its hard strata of soil. Whenever it touches hard strata of soil, they will pour granule material on this. This all things will be happen after inserting another uh, column, etc. All things. The next and the the next technique I will mention, that is soil nailing, in which we insert the bars in the soil. Let's start this video. It is very interesting. Inserting the steel bars. Preparing concrete and clamp it by one side of the soil. So conclusion of the ground improvement is not only cheaper but reduce the construction time significantly. Conscious effort to prepare and follow up the techniques will lead to use a successful completion of the project. We are now technically sound at hand. We have different types of soil. And also we have different methods for that. Not for the sand, like saturated sand, we have another method use Vibro Compaction. We have the different types of soil, and these types of soil we use different method for these soil. And typical spacing, attained improvement, advantages of these methods, and limitations of also these methods, and also the cost of these methods are seeing here. So this is all from my side. Thank you very much.
Okay, thank you so much, Ehtisham. I particularly liked about your presentation when you were emphasizing on the engineering properties of the soil. Okay, that was one part when you mentioned about increasing or enhancing the shear strength of the soil and decreasing the permeability and the compressibility of the soil. So that was really good. But I also enjoyed your animation related to Vibro compaction method. When you were presenting in your video, that was shown that there are rollers there which is compacting the soil. There are also CPT test rigs there, so you find out the tip resistance and sleeve friction for the uncompacted or unimproved soil. And then after the improvement, there was another CPT test rig was also there to find out the shear strength of the soil. So that was also interesting. And we also saw that plate load test was also performed, and we can also perform the pile load test. So in that one video you can see different field tests which are used in the field of geotechnical engineering. So thank you so much for your excellent presentation. And again, if you need any help in boosting your sessional marks or in rechecking, just please let me know after your final term. Thank you. Next presenter, please.
Assalamu alaikum, sir.
Walaikum salam. Your screen is visible and
Okay,
your voice
sir.
is clear. Time
Okay,
is
sir.
9:37 a.m. and please try to finish your presentation within
Okay, sir.
10 minutes. Thank you.
Okay, sir. Bismillah Rahman Rahim. I am Fuad Iqbal and my teammates are Ijaz Ahmad and Muhammad Idris. Today, the topic of my presentation is the ground improvement. So, during my presentation, I will be passing briefly through these topics: the ground improvement, understanding the ground factors to be considered, field compaction. Now, these five are the techniques which we use for the ground improvement: the field compaction, the dynamic compaction, the Vibro Compaction, and the preloading vertical drains concept. And then the ground freezing. So what is ground improvement? As we can see clearly from this terminology, that it is the improvement of the ground. Ground improvement is application of various geotechnical techniques that are used to re-engineer existing soils to improve their engineering characteristics. Ground improvement techniques may include soil stabilization, Vibrostone columns, jet grouting, deep soil mixing, and dynamic compaction. So what happens is that the soil is not if we are going to build a structure on a soil, so this is always not the case that the soil is in the desirable conditions. So what we do is that we improve the soils to remove the problems of consolidation and settlements, etc. The ground improvement includes two parts. The first part is to understand the ground. So for this we do reconnaissance survey. We first what we do is that we go to the site and inspect perform different tests that what type of soil is this is and what is in the surrounding of the soil and also the history of the soil. So we study about the soil in detail. Then find out the most engineered solution for the improvement. So uh, after getting a lot of information about the soil and surrounding, then we go for the improvement techniques. So we go for the most engineered solution. It means that we go for the most economical, the most durable, and nowadays we also go look to the time factor. We go for a solution which takes less time because nowadays the world is moving faster. So we engineers try to take as lesser time as possible. Understanding the ground. So common geotechnical people understand it as a problem of soil or sometimes designating it as a problematic soil. So understand first that no soil is problematic. It's a combination of situations which makes soil to behave problematic for a human purpose. So it is not fair to use the word problematic soil. Actually, actually the soil can be improved. So the engineers and the designers should improve the soil before execution of the plans. Don't just consider a type of soil. So we need to take different factors into account. Lots of many factors play a governing role to create problematic ground which needs to be improved. Now, what are those factors? Uh, what are those factors apart from the characteristics of soil which should be considered? So the type of structure to be considered or improved soil, like suppose you are having the same site and you are going to build a five-story structure on that, and then on the same site, suppose you are going to build a skyscraper. So these are now two different factors, and there will be different techniques and a different level of understanding for both of these which and also then, which again decided the nature of loads and subsequently the type of foundation requirement. So we should also know that what the soil is supposed to take, what type of loads in the future. Like we know that dynamic loads are much more dangerous than the static loads. So we need to take different factors into account. Vicinity of the coastal area. We should know that what is in the vicinity of that site. Like suppose it is actually not the case most of the time, but suppose say you are having a dam and that 1 kilometer away from that dam you are going to construct something. So of course there will be problem of seepage and flash floods and lots of other problems. Earthquake prone zone, like so different techniques will be used for earthquake prone regions like or the Sawat region, and then for other regions which are not earthquake prone. So different approaches will be carried out for these different factors. Chances of flash flood due to dam burst, geology beneath the improved site, and also the geology of the area. So we also need to have a firm knowledge about the geological characteristic, that what type of strata is beneath the soil, beneath the soil, and what is the underlying strata. Average seasonal and yearly temperatures. Okay, so ground improvement is very important. You can see you can see in these pictures that designers did not take the ground improvement into account. So these are the consequences. You can see the first picture is the Leaning Tower of Pisa, which is the most famous in this regard. The Leaning Temple of Dome in India, and the Lotus River Site Complex in Shanghai. Now you can the first one. This is now you can see that you are having the leaning or tilting of the structures have occurred. Now if you see this case now, this is even more dangerous. The sinkholes problems. What is the sinkholes appear when the water underneath erodes the soil. So you are having a lot of stress form. So the structure will settle down excessively. You can see this is a very expensive structure, but due to not taking the ground improvement into account before execution of the plan, now this is the consequence. Now there are a lot of methods of ground improvement of the soil. The first one is the field compaction. So this is the least expensive method because we simply use the road loader, and road loader are easily available. This is the simplest method. It does not require complex machineries. When you are using complex machineries, so it will be also difficult to operate them. So in that sense, this is also a simplest method, applicable to both cohesive as well as non-cohesive soils. And now this is the formula, the dry grade formula, which we have used throughout engineering courses. So we use this formula. Now the equipment which can, there are a lot of equipments which can be used for this type of compaction, but the most simpler one is a smooth wheel ruler. So the one benefit of it is that it covers 100% coverage area under the wheel. You can see here that whole area is covered. Now the contact pressure is up to 380 kilopascals and can be used on all soil types except for rocky soils. Compacted for static weights separate. Then you are having a dynamic compaction. So as clear from the name, it is dynamic. So you are applying the load, then removing, then apply. Like we have performed the test in our geotechnical lab. When when it is used, when the existing surface or near surface soil is poor with regard to the foundation support, and for which type of soil it is used, so for both cohesive and non-cohesive, and for both cohesive and cohesionless soils. So for sand type and sill type, for all of the types we can use it. And how we use it? So drop a very heavy 2 to 20 tons weight on the soil from a relatively greater height, 20 to 100 feet, and dropping. So it is a question: does we drop the weight randomly? No, because then that will again create problems if we drop the weight randomly. So what we do is that first we first what we do on the side, that we create a pattern, a grid system, and then using that grid system we apply the loads in the particular points. Now you can see this is the machine and this is the compaction. So of course, when this load is falling down, so it will compact, and compaction means this will also remove the water, the water which will be in the pore. Suppose you are having a structure and you design that structure for 50 years, but when you do the calculation, you come to know that after 40 years, what will happen is that the structure will be exposed to severe settlements. So you do this compaction before execution of the plans, and then in the long term you will not face those problems. Vibro compaction is then another technique. Vibro compaction is a technique for in situ densification of thick layers of loose granular soil deposits. It was developed in Germany in 1930s. Now the preloading vertical drains. So vertical drains are installed under a surcharge load to accelerate the drainage of impervious soils and thus speed of consolidation. These drains provide a shorter path for water to flow through to get away from the side. Time to drain clay layers can be reduced from years to a couple of months. Now this is a very effective technique. If you see, the time to drain clay layers can be reduced from years to couple of months. So the concept is simple. You apply the load. So it's a common phenomenon. Then if you apply a load, compaction will be occur, and the water in the pores will be removed. So then you will be having no effects in the long term, because you have already removed the water from the pores, and the proper compression have occurred. Now the ground freezing technique. Okay. Ground freezing is a process of making water-bearing strata temporarily impermeable, and to increase their compressive and shear strength by transforming joint water into ice. Now it is a temporary technique which is used. We convert the water into ice. Ground freezing, the construction technique that is used in the construction of shops, mines, and tunnels to provide temporary earth support and groundwater control, when other conventional methods such as dewatering, shoring, grouting, or soil mixing are not feasible. Now we can see this is a picture. Here our aim is to froze our underlying water. So the temporarily we froze the underlying water in the soil. So you can see here in the picture the liquid nitrogen is used. Thank you. This was all from my side. Actually, there is a lot to tell about each and every topic, but due to the limited time, I tried to make it as simpler and as brief as possible. You
Thank
are
you
the
so much, Fawad.
thank
Thank you. The thing is that you are given that time frame. The reason behind that is that you need to summarize, you need to present all those methods briefly. So we don't want to go into very detail, but we need to know as a undergraduate student. It is very important to know that what are the different ground improvement or ground reinforcement methods which you are going to see once you graduate. So thank you so much for your excellent presentation, and just let me know if you need any help in boosting your sessional marks and rechecking of your final term paper. Thank you.
Okay, sir. Thank you,
Next
sir.
presenter.
सर मैं प्रेजेंट करना चाहती हूँ.
Okay, please continue.
Okay. My screen is visible?
Yes.
Okay. My name is Hira. My class number is 37. Today the topic of my presentation is soil improvement techniques. The content of my presentation is introduction, techniques, Vibro Compaction, vacuum consolidation, preloading of soil, soil stabilization by heat, ground freezing, Vibro replacement, micropiles, grouting, soil milling. Before the starting of the presentation, let me clear that why we need to improve the soil. We need to improve the soil. For example, if we want to build a structure and there is a problem in the engineering properties of soil, like elasticity, compressibility, cohesion, permeability, then after the construction, maybe the building collapse. So that's why we go for soil improvement techniques. What are the techniques? The techniques are Vibrio Compaction, vacuum consolidation, preloading of soil, soil stabilization by heating, ground freezing, Vibrio replacement, micropiles, grounding, soil nailing. Vibrio Compaction. Vibrio Compaction increases the density of soil by using powerful depth vibrators. Here you can see in this video. A vibrator is attached with the crane and with the help the freeloader is the inloader is adding the soil, which increases the bearing capacity of the soil. Vacuum consolidation. Vacuum consolidation is used for improving soft soils by using a vacuum pump. Here you can watch in this video that in Netherlands how they adopt this technique.
The Baudry-Ness technique. It's a vacuum consolidation technique which uses a vacuum pressure to accelerate the consolidation. With the use of pressure difference inside the drain, you can save about 2.5 meters of sand compared to normal vertical drains. Or if you use a little bit more sand, you can accelerate in time. System.
These pipes are used. These pipes are known as prefabricated vertical drains. Which drains the water inside the soil. The pipes which are above the ground are called VTP, vacuum transmission pipes. which are connected with the PVD fabricated vertical drains.
The lines are connected to a manifold, and then the manifold is connected to a pump, and then the pump is, after a testing that the whole field is closed, like no air leaks are present, then the whole system is turned on and the pumping starts.
This pump sucks all the water inside the soils.
And after the pumping period, maybe a week, maybe 2 weeks, after it's already settled, additional layers of sand can be placed on top. As a quality control, we can install piezometers inside the drain, just to measure the under pressure that's developing inside the drain.
Now, preloading. Preloading method is used to remove pore water or time to increase bearing capacity of soil. Soil stabilization by heating. The thermal stabilization can do in by heating the soil. When the soil heat, then the water content of the soil decreases. Thus, electrical repulsing between the clay particle decreases and the soil strength increases. Ground freezing. Ground freezes convert pore water to ice to increase their combined strength and make them impervious. Vibrio replacement. Vibrio replacement stone columns improve the bearing capacity of soil, whereas Vibrio replacement method displaces the soil. Here you can see in this video that how it works. With the help of drill machine, we inserted a griddle or chisel in the columns, which makes stone columns and increases the bearing capacity or other properties of the soil. Micropiles are smart diameter pipes up to 300 mm with the capability of sustaining high loads, compressive loads of over 5,000 kilonewton. The drilling equipment and methods allows micropiles to be drilled through virtually every ground conditions, natural and artificial, with minimal vibration, disturbance, and noise at any angle below horizontal. Grouting. Grouting is a technique in which we insert a material into the ground which fills the voids and cavities and reduces the permeability of the soil. Soil nailing. Soil nailing is a construction remedial measure to treat unstable natural soil slopes or as a construction technique that allows the safe or steepening of new or existing soil slopes. Alternatively, a flexible reinforcing mesh may be held against the soil face beneath the head plates. Soil nailing is mostly adopted in the places where there is possibility of landsliding, like Murray Goliath, etc. Thank you so much for hearing my presentation.
Okay, thank you so much, Hera, for your excellent presentation. I particularly enjoyed the video of the vacuum loading. That is also a little bit related with the PVDs as well. So it was really interesting, and thank you so much.
Thank you, sir.
Okay, who is the next presenter, please? Anyone who wants to present, please kindly share your screen.
Sir, I think the people present here All have done in groups.
Okay, so thank you so much for Muhammad Nadeem, Adnan Sami Khan, and Sami Wasim Khan, Muhammad Ihtisham Arshid, Fawad Iqbal, Hira Wahab. I particularly enjoyed each of your presentations, and those presentations were really interesting for me. I wish you best of luck for your exams. I know you are busy with the complex engineering problems and other quizzes and assignments and other tasks. So thank you so much. And if you want to leave, you can leave. And just to let you know, all of you, that if you need any help in boosting your sessional marks and rechecking of your final term, or if there is few marks missing in your grade and that can be improved from, for example, B plus to A negative or something like that, from A negative to A, so I will definitely help you with that. Thank you so much
Thank you so much,
for
sir.
your
Thank you so much.
presentations.
Thank you, sir.
Okay, Allah Hafiz, Assalamu alaikum, take care.
Thank you so much, sir. Allah Hafiz, sir. Assalamu alaikum. Assalamu alaikum, sir.
Thank you, sir.
Wa alaikum salam, take care.